Hi, welcome back to my channel. My name is Gina. In this video, we are going to cover another technique to solve an integral, the integration by parts. When do I use integration by parts? First, if the integral is not a basic integral. Second, if the u-sub fails. If you want to review the basic antiderivative and u-sub, I'll put the videos up there. And third, that is the big hint for you to use the integration by parts. When the integrand is a product of a polynomial and trigonometric or exponential functions, or a product of polynomial and arcsine, arctan, arcsecant, and ln. And third, if the integrand is a product of a trigonometric function with an exponential function. Here are some examples. The first integral is a product of polynomial with exponential function. So when you see this type of integral, that is the hint for you to use integration by parts. And in the second integral, you have a product of polynomial with arctan of x. And the third example, you have product of exponential function with trigonometric function. So now let's derive the integration by parts formula. To derive the integration by parts formula, I need to remind you something from Calculus 1, the product rule. The product rule says when we have derivative of a product of two functions, for example, derivative of f times g, then from the product rule, it says this derivative equals to f prime times g plus f times g prime. Now let's take the integral on both sides. On the left-hand side is integral of derivative of f times g. And the right-hand side is integral of f prime times g plus f times g prime. On the left, we have an integral of a derivative function. And by the fundamental theorem of calculus, it equals to the function inside the derivative, which is f times g. And on the right-hand side, we can use the property of integral to separate the integral into two integrals. The first one, integral of f prime times g, plus the second integral, integral of f times g prime. Now we want to isolate for this integral. So integral of f times g prime equals to f times g, the left-hand side, minus the remaining terms on the right-hand side, integral of f prime times g. And this is our integration by parts formula. Now let's look at some examples. The first one, we have integral of x plus 1 times e to the power of x. So here in the integral is a product of polynomial with an exponential function. So that is a hint for us to use the integration by parts. In the formula, it says the integral is f times g prime. So let f equals to x plus 1 and g prime be the exponential function. So now the integral is integral of f times g prime. And to use the formula, the right-hand side we also need to find the f prime and g. F prime, the derivative of f function, which is 1. And g is the antiderivative of g prime, e to the power of x. The antiderivative of e to the power of x is still e to the power of x. So now we can substitute these 4 functions into the integration by parts formula. It equals to f times g. F is x plus 1, and g is e to the power of x. Then minus integral of f prime times g. F prime is 1, and g is e to the power of x. So this equals x plus 1 times e to the power of x minus integral of e to the power of x is e to the power of x. And remember to add some constant at the end. Now let's look at one more example. Integral of 2x plus 1 times ln of x squared. In this integral, we have a product of polynomial function with ln of x. The first step is to find f and g prime. And since it's easier to find the derivative of ln of x, so let f equals to ln of x squared. And g prime is 2x plus 1. So f prime derivative of ln of x squared is times ln of x times 1 over x using the chain rule. And g, antiderivative of 2x plus 1 is x squared plus x. Now we substitute these 4 functions into the formula. We'll get ln of x squared times x squared plus x, which is f times g, then minus integral of f prime times g, times ln of x times 1 over x, and g is x squared plus x. So it equals to ln of x squared times x squared plus x minus 2 integral of ln of x times x plus 1 dx. And here again, in the integral we have a product of ln with a polynomial function. So let's use the integration by parts again. Let f be ln of x and g prime be x plus 1. So f prime is 1 over x and g is x squared over 2 plus x. So this integral equals, the first term remains the same, then minus 2 times ln of x times x squared over 2 plus x minus integral of f prime times g, which is 1 over x times x squared over 2 plus x. Which equals ln of x squared times x squared plus x minus ln of x times x squared plus x and integral of x plus 1. The first 2 terms remain the same. In the third term, integral of x plus 1 is x squared over 2 plus x. And remember to add some constant at the end. That is the end of the video. If you are interested in Calculus 2, I'll put the link to my online course on Calculus 2 down below. If you like my videos, please like and subscribe, and I'll see you in the next video.